teach you the bare bones basics on how to get the natural domain of a function. So let's begin. First, let's start off with what is the natural domain of a function. It's basically wherever the function is defined, and that basically means whatever x can be, what you can input for x. So let me give you an example. The natural domain of root x is x must be greater to or equal to 0 because you can't take the root of negative numbers. Find the natural domain of f at x equals 5 minus the absolute value of x plus 1. Pause the video for a moment if you need a moment to figure it out. Okay, so the natural domain is all real numbers. There are no restrictions to this because you could put anything for x. So it's x is all real numbers. The interval for this would be from negative infinity to positive infinity. No restrictions. Find the natural domain of f at x equals root of 2 minus x. Pause the video if you need a moment to solve this yourself. Okay, so the solution to this is there's a root, which means you can't input negative values into the root, so you have to set up an inequality. Do 2 minus x must be greater than or equal to 0, because as I said before, you can't input negative numbers into the root. So you have 2, you move x to this side, so you have x is less than or equal to 2. So x can't be greater than 2. Domain of f at x is equal to 1 over the root of 2 minus x. So this is very similar to the last problem, the only difference being that the root is now in the denominator. And so this is pretty important. You have to pay attention to this because the difference is that you can't have 0 as the denominator. So just like before, you're going to set up an inequality for the root. You're going to have 2 minus x is greater than 0. See how you don't put greater than or equal to 0 because you can't have 0 as your denominator. So you just solve the inequality by moving x to the other side, and then you have x must be less than 2. And so if you wrote this in interval notation, it would go from negative infinity to 2. And you use round brackets for the 2. You don't use square brackets because 2 isn't included. Because if you equal 2, the denominator will be 0, so it's not included in the domain. I want to find the natural domain of this function right here. Now this may look scary at first, but all you have to do is find the restrictions of each part of this. Just break this down to parts, find the restrictions of each one, and then combine the restrictions at the end to find the natural domain of it. Let's start with this portion right here. You see that there's a root symbol, so you want to set up an inequality because you can't take the root of negative numbers. So let's do this. X over 4 minus 1 over x minus 3 must be greater than or equal to 0. And then you get a common denominator. You could do this by cross multiplying these. So you have x times x minus 3 minus 4 divided by 4 times x minus 3 must be greater than or equal to 0. Now you just expand it. You just expand these, but not the denominator because this is already factored. So you expand this to get x squared minus 3x minus 4 over 4 times x minus 3 must be greater than or equal to 0. And then you factor this top part. This factors out to x plus 1 times x minus 4 divided by 4 times x minus 3 must be greater than or equal to 0. And so this gave us some critical values. This gave us some split points that we can use to test where the function is positive and negative. So our values are x is equal to -1, 3, and 4. We got these values by seeing what makes the function equal to 0. So we got -1 from this, we got 3 from this, we got 4 from this part. And so we test these values on a number line to see where the function is positive or negative. Let's make a number line right here. Okay, now let's plug in a really large negative number into this. Let's see what we would get. We would get a negative times a negative divided by a negative. So that would give us a negative value. So we put a negative sign right here. Now let's say we plug in a value in between -1 and 3. We would get a positive times a negative divided by a negative. So that would be a positive, because if you do positive times a negative divided by a negative, these negatives cancel out to give you a positive. So this is positive. The function is positive in between -1 and 3. Now, let's plug in a value in between 3 and 4. Same concept. You would end up getting a negative value. And then a really large positive number, you get a positive value. Okay, so this shows us where the function is positive and negative, where it's above and below 0. So we use this to answer the question. So the domain is in interval notation. The domain of the function would be from -1 to 3. And from 4 to infinity. This is how it would be in interval notation. But you can't put round brackets, you can't put square brackets for the 3. 3 isn't included in the denominator. The reason why it isn't is because it's not included in the function. The reason why you can't put square brackets is because if you would put x is equal to 3, it would make the denominator equal to 0. And that would make the function undefined, because you can't have 0 as your denominator. The other restrictions of this question, let's do this part next. Sine of e to the x. This has no restrictions. You could put anything for x. You could put any number. So this gives no restrictions. Now let's move on to the next part. Ln of 2x plus 1 over 2. Now this does give restrictions, because you can't take the ln of negative numbers or 0. So it has to be, so we set up an inequality for this. 2x plus 1 over 2 must be greater than 0, not equal to 0, because you can't take the ln of 0. So when you solve this inequality, you'll get x must be greater than -1/2. Okay, so and the interval notation for this would be negative a half to infinity. Okay, so now that we have the restrictions for each question, we can combine all the restrictions. So from the previous question, we got the restrictions where the function is defined, so let's just combine them. The final restrictions would be negative a half to 3. Again, round brackets because because it's not included in the domain. For this question, it's round brackets, and for this question, it's round brackets because this can't equal this because ln can't equal 0. You can't ln a negative number or a 0. From negative a half to 3, and from 4 to infinity. That would be, this is the union symbol, it means and. So this is the final answer for the natural domain of that question. Domain of this function, cube root of 2x minus 1. Okay, so the answer is actually, it has no restrictions. The answer is all real numbers. X can be anything. You can put anything in for x. It's from negative infinity to positive infinity. The reason for that is because it's a cube root. It's an odd root, not an even root. You could plug in a negative value into this, and because it's a cube root, it'll end up as a positive value. So remember that rule. If you could put in negative values for a cube root or an odd root, but not for an even root function. Okay, so that concludes all the examples I wanted to cover. Thank you for watching.